Thank you, Sunil, for that lovely introduction. So I'm here today to introduce to you a joyous approach to maths facts. But I'm going to start off by sharing a little bit of research on why we need this approach. And the first study I want to share with you is this one. These researchers brought in 72 students between the ages of 7 and 13, and they'd been nominated by teachers as being low, average, or high achieving students. And then they gave them maths problems to do with visual representations, such as this one, arithmetic problems, 7 and 19. And then they looked at the kids' strategies. So these were the 4 they recorded. The most basic kind of strategy, some students counted all of the dots. Slightly more developed strategies when they counted on, so starting at 7 and then 8, 9, 10 and continuing on. Some kids just remembered that maths fact, and others used number sense. So they dealt with the numbers flexibly, and instead of adding 7 and 19, for example, they added 6 and 20. And this is what they found. Amongst the low achieving students, 61% of them were using number sense, but amongst the high achieving students, 61% were using number sense, but amongst the low achieving students, no students at all used number sense. 72% of them counted on, and 22% of them counted all. And I won't share the whole study, but one of their important conclusions was that the difference between the low and the high achieving students was not that the high achievers knew more, but that they engaged with numbers flexibly. And they also pointed out that the low achieving students were learning a different mathematics, which is actually more difficult. So for example, when they got the problem 16 minus 13, the low achieving students counted back. They started at 16 and counted down 13 numbers, which you'll probably appreciate is pretty complex to do. But the high achievers took 10 from 10 and 3 from 6. So this is something that a lot of research is telling us now about low achieving students, is that they are not engaging with mathematics flexibly. And this comes about when students are given the idea that what they should be doing in maths classrooms is just memorizing. More evidence that I wanted to share with you, I've worked with the PISA team. They give tests out to students worldwide, and we were able to look at a database of 13 million 15-year-olds. We were able to put the students into categories depending on their learning approach. 3 approaches were these. Some students memorized their way through maths. Others saw it as a conceptual subject, and some others were more reflecting about different approaches. And this was sort of the headline result that we published. The lowest achieving students in every single country were the memorizers. And any country with high numbers of students, high numbers of memorizers was a low-performing country. The US is one of those countries. So how do we get students engaged in flexible thinking? So I want to share a little bit of brain evidence around flexible thinking. And one study that was reported actually in National Geographic recently, they looked inside the brains of living people that they regard to be trailblazers, the most high-achieving people. And this is what they find to be the difference between these trailblazers and regular people, is that they have more communication going on between different pathways, more flexibility in their thinking. So some very recent Stanford evidence about brain pathways I wanted to share with you. Every time people work, even on an arithmetic problem, there are 5 different areas of the brain involved. 5 pathways, and 2 of them are visual pathways. So our brains actually want to think visually about mathematics. And when we see maths in different forms, exploding dots, numbers, algorithms, it causes communication between these brain pathways. When we see mathematics in one form, numbers, that stimulates a part of the brain but doesn't have this communication. And more research is showing that our brain is made up of these distributed networks. And if we want people to think flexibly, we have to have those networks interacting with each other. So young kids really go down 2 different pathways in mathematics. One, for many young students, they think maths is about memorization, they take timed tests. Other kids develop number sense, they think about numbers conceptually. One of those routes leads to maths aversion and maths fear, and the other leads to a very important foundation mathematically. So other research I wanted to share with you, we now know that when people are stressed by maths, the part of the brain is impeded, the working memory. And in fact, the working memory is where you hold maths facts, where you process maths facts. But when kids are anxious, their working memory is impeded. They really can't access it. So what do we do to little kids in classrooms? From our local districts around here, 50 questions to take in 3 minutes from first grade upwards. These are the beginning of maths anxiety for kids. Yet they are used all across the country, which is part of the reason we have a nation of maths anxious people. And more interesting evidence that's coming from Stanford neuroscientists, we now know that if you're anxious about maths, when you see numbers, a fear center lights up in the brain. That is the same fear center that lights up when we see snakes and spiders. So what do we do with this widespread maths anxiety? I can tell you I teach a class at Stanford. It's called How to Learn Maths, and every year I get a huge proportion of this class are maths traumatized. Every year I ask them what happened, when did this happen, and virtually every student pinpoints the time they started taking time tests. Many of them became anxious in those moments. Others very often say to me, that was the time I realized that maths was about the shallow recall of facts, and so I turned away from the subject. So we even have brain evidence of what happens when you teach maths facts in different ways. This was an fMRI study where they compared people who blindly memorize maths facts, as many people have done, with people who learn maths facts through engaging with strategies. And what they find is those two approaches to maths facts cause different parts of the brain to be active, but both of them are perfectly, they work and you can recall maths facts afterwards, but with no difference in reaction times, although they did find that the strategy group were better able to use maths facts over a long time. So we have a lot of evidence that we don't want to teach maths facts through blind memorization, but teachers quite often ask me this question: if I don't use time tests, how can I teach maths facts? They are so tightly coupled in teachers' minds because they themselves have had the experience of multiple time tests, and to them that is what maths facts are. So I'm actually hated by a lot of traditional maths people on Twitter and lots of other places. My name is dragged through them every day. But often the tool they use to attack me is to say, Joe Boaler hates math facts, and Joe Boaler thinks math facts shouldn't be taught. Well, it turns out that's not true, as with many of the things that are put on social media. And a couple of years ago, we released this paper. It's on our website. You can Google it if you want to find it later. It's called Fluency Without Fear. And it's about how kids can become fluent and really able to use maths facts well without what we would hope we don't want to give them, which is fear and anxiety with maths. So I wanted to highlight for you one of the activities that's featured in that paper. It's called How Close to 100. I love this activity. So kids have a 10 by 10 grid, and they play with another child who has their own 10 by 10 grid. They roll a dice, and they get two numbers, and then they write that maths fact on the grid, but they also draw a visual representation of the maths fact using a rectangular array. And the goal of the activity is to fill the grid. So you have to be kind of strategic where you're putting your rectangular arrays. But this is a perfect activity for kids to learn maths facts. They remember them, but they also can see them visually. So brain connections are happening. They get an understanding of what those numbers really mean. So I'm really excited today to premiere a film we've just made to try and get this message out to more teachers. So this has never been shown publicly before, but it's a little video that shows students in these two different approaches to maths facts. So as we watch this video and we watch these young students engage in these activities, I'd like you to really try and think about, what do they think about maths as they're doing this? What do they think it is? So that, thanks. That video is on our website under the other films, so please share it. I'm going to put it on Twitter later today, actually. But there are other approaches to maths facts that also teach maths flexibility with numbers. We really like number talks, where teacher, that's me working with students on a number talk, gives a maths problem, such as 18 times 5, for example, and then ask students how they solved it. And we like to collect their different methods, put the student's name on them, also visually show, because that really helps with those brain connections and with understanding. But I wanted to tell you a little, some interesting things that have happened to me around number talks. I taught them in an online class, and after I'd taught them, I had a call from a teacher in England, and he phoned me up and he said, "Oh, I must tell you, I learned about number talks, I really like them. I went and did one with my top set kids, the highest track, and it was great." He said, "I asked them to do 18 times 5, they came up with all these different ways, we talked about them." He said, "Then I went and did the same number talk with my bottom set kids, and I put up 18 times 5, and he said there was complete silence, nothing. And I waited and waited, and eventually I said to the kids, you know, what about if we do 20 times 5? And he said, the kids looked at me and they said, "But sir, we didn't think that was allowed." So this sort of illustrates what I showed you in the research study. The high-achieving kids are dealing flexibly with numbers. The low-achieving kids often think that you cannot do that with maths, that you have to be very rigid. And I've also had, interestingly, I talk about these in my book, and I had an adult come up to me and say, "I saw those different ways of solving 18 times 5, and it's not as though I didn't know you could do that, but I somehow thought it wasn't allowed." So here we go again with this idea that and many people have in the population, that mathematics is very rigid, you can't deal with numbers flexibly. So often when I'm presenting these ideas to people, they ask me this question. They say, "But what about making kids fluent and practice? We want them to practice, don't we?" So this is what we know about practice. Practice is good. It's what, develops brain pathways. But if you talk to neuroscientists, they'll tell you that seeing the same idea over and over and over again with the same numbers is not what's productive practice. And what is productive is actually to see it in different ways, different forms, different representations. And I wanted to tell you a story of my own parenting with my own children, and they're in middle and high school now. I have 2 daughters, but when they were in elementary school, they went to a school that fortunately did better maths homework. I'd rather there's no homework, but they gave them puzzles and ken-kens, little puzzles, and that was good. But occasionally they would come home with something like this. And each time there would be tears, frustration, why teachers think that this is what children should be doing in the evenings when they're tired. I don't know. I don't do things like this in the evenings when I'm tired. But anyway, I'm always very supportive of my children's teachers. I was a teacher. I know it's a very important and challenging job. But I must have been tired this particular evening or something. My daughter was 8 at the time. She brought home this kind of worksheet, and I wrote a little note on the worksheet to the teacher. I wrote, I've got my daughter to do the first few of these questions. I've asked her not to finish the worksheet because I don't want her to think this is what math is. So I thought that was kind of subtle and supportive. So anyway, we ended up having a chat, and it was great. And now she doesn't give these worksheets, but instead she still gives a calculation. But she asks kids, "Can you do 4 of these? And as you do the calculation, can you also write a story about this particular mathematical idea and draw 2 visual solutions?" So this is perfect. They're practicing. No longer are my children crying at bedtimes. They're happy to write their own story. They're happy to draw a picture. Brain connections are happening. So I wanted to, as we think about maths facts, I wanted to share a joyous maths event. So you'll recognize this 12 by 12 multiplication table. What I think of, many students think of this as an instrument of torture, that when they have to memorize it. But of course, we all know this is actually a really interesting set of patterns, as Sue was talking about, that we can actually get a lot of meaning from. And we often give this table out to teachers and say, what patterns do you see in here? And often they see vertical patterns, they see horizontal patterns, they sometimes see diagonal patterns. But recently, while we were working on a new book series, my team and I noticed this interesting set of patterns. So here we see those 12 numbers that we were hearing about from James earlier. And really interestingly, they are connected in these curves. So when I saw this, I thought, this is really cool. And I took a little picture and I put it on Twitter. And I said, look at these curves in the multiplication table. Where are they coming from? How interesting. And I wanted to tell you what happened next, because it was kind of cool and interesting. So first of all, the teachers jumped in. And somebody said, oh, I got my students to run a workshop on this today. For parents, loved it. Then the teacher said, what? There's a line of symmetry. And another teacher said, yes, and your line of symmetry goes to the perfect squares. So great, lots of conversations from teachers. Then the mathematicians jumped in. So we have some here. It's hyperbolic, they're talking about the nature of the curves and the equations. But my favorite mathematician comment on this came from Chris Sanguin, who's at the University of Edinburgh. He said he looked at the little visual I put on Twitter and he felt inspired, so he made this. So this is on our website. We love to give tasks that we say are low floor and high ceiling. Everybody can access them. They go to high levels. We thought this was a great example of a low floor, high ceiling task. The little kids are engaged. The mathematicians are also really engaged. But we can take all sorts of numbers, including maths facts, and really dive deeply into them. So a last example I wanted to share with you, just this past week with my undergrad class, I gave them a problem that I love, and we have 3rd, 4th, 5th graders work on this problem. The problem is you have 4 fours, you have to use all of them, and any operation, and try and make every number from 1 to 20. So they got so excited about this, started using all sorts of different mathematical operations, and through this task, we introduced a lot of young children to factorial. They love factorial. Why do we keep factorial? Or even Euler's phi. Why do we keep these for high-level students? But anyway, they loved it, and they talked about it was so cool. We could use complex ideas with simple numbers, so much variety. So I just would like to underscore that, in mathematics, we can always see more and discover more and explore more. This is one of our lovely unpacking of numbers that we have on our website. So that's all I was going to share. If you want to see more about what I've talked about, UCubed is our center at Stanford. This is a book. And how do we teach maths facts joyously, with flexibility, with patterns, with valuing multiplicity, multiple ways, valuing those brain connections, and of course, teaching number sense. Thank you.